Good morning, 7th graders. We are on our last lesson of the school year. Okay, we are on page 87, lesson 11, comparing graphs. Okay, there'll be one new term I want to make sure we talk about. It's called MAD, mean absolute deviation. We'll talk about that in a minute. First question is, just looking at these two groups, what do you notice? What is one thing you notice? Looks like the women's gymnastic team is quite a bit shorter than the men's volleyball team. Okay, other things you might wonder, how much taller is the average of the volleyball than the gymnastics? What are the heights of the female volleyball players compared to women's gymnastics? Does the number on the team differ, or is the same number on the volleyball team as gymnastics? Okay, so just one thing you notice, one thing you wonder is all you need there. Okay, question number 2. Now instead of having a visual, it gives us to it in a list, gives us the information. How much taller is the volleyball team than the gymnastics teams? Okay, now it doesn't really give us much information. Does it want us to analyze the mean? Does it want us to analyze just the maximum? The tallest from each? The smallest from each? It doesn't really give us any information, so technically you can answer anything you want. I might say that the shortest volleyball member is 13 inches taller than the tallest gymnastics member. Okay, so it doesn't really give us information to solve that. So pick out one piece of data and go ahead and analyze that. You can analyze, again, the maxes, the mins, or find the mean of each. Doesn't matter. Doesn't give us any information. Okay, make a dot plot to compare badminton and tennis. And a dot plot is just going to be putting a dot where the heights are. Okay, so I already have that one done, so I will show you that, and then you can pause it and write it in there for you. Okay, there's the dot plot of the badminton and tennis team, so go ahead and pause that so you can make that. Okay, and once again it says, what do you notice about your dot plots? Well, what do you notice about this dot plot? Okay, I would say they're closer together in heights than the volleyball and gymnastics were. The tallest person of each is only 3 inches difference in this one. The shortest are only 4 inches different. They're probably closer grouped than our first dot plot we looked at, so whatever you need to make there to compare them is fine. It just says one thing you notice is just fine. Number 3. Elena says the members of the tennis team were taller than the badminton team. Lynn disagrees. Do you agree with either of them? Okay, tennis team is taller than the badminton team. Okay, again, that's not the case for all of them. You know, if you look at this person that is 67 inches tall for the tennis team, there are 3 people taller than the badminton. You know, in general, they're taller, but you can't say they all are. Okay, this person that's 73, there's only 4 people taller on the tennis team. So again, different ways to analyze it, different ways to compare the data. Okay, so we're going to talk about different ways. Again, just make one note on if you agree with that statement or not. I do not, because it doesn't, you know, to me that says all the members, and that wasn't the case. But again, it's basically your opinion as long as you explain why. All right, 11.3. Compare the heights, explain or show your reasoning. Okay, comparing the heights of the two families. So how about if we figure out the average of them? Okay, we could make a dot plot again and analyze that. We've already looked at 2 dot plots. So I'm going to add up Noah's family. 28, 39, 41, 52, 63, 66, and 71. I got a total of 360, and I'm going to divide that by 2, 4, 6, 7. 360 divided by 7 is about 51.4. Jada's family, 49, 60, 68, 70, 71, 73, 77. You got 468 divided by 7. And I got 66.9 about. All right, so on average, I would say Jada's family is taller. And again, explain or show my reasoning. I computed the mean or the average, and it's about 15 inches taller. Okay, now, how about if Jada family adopts newborn twins who are 18 inches tall? So on top of this, now they're adding 2 more 18s to it. So it's 468 plus 36. Now the total height of Jada's family is 504, and I'm dividing it by 9 people now. And I get 56. So Jada's family is still taller, but it is a lot closer if you add 2 newborn twins. So you can see how the mean can certainly be affected. Okay, 11.4. It says here are the dot plots. Oh, I want you to write down one equation. Okay, the mean absolute deviation this problem is going to talk about. That's how far things are away from the mean. How close are your data points grouped together? Okay, here are the steps for finding it. Find the mean, the average. We just did that twice here. Okay, and then you figure out how far each number is away from the mean. Then we add up all those numbers together. And then we take whatever we get when we add them up, the sum for number 3 here, and you divide it by how many points you have. That will make more sense as we do one, but that is how you figure out the math. Okay, 11.4 on page 89. One of these data sets has a mean of 5.57. One has a mean of 3.91. Which dot plot shows each of these? Okay, so which one do you think has an average of 5.57? Okay, well there's no way it can be B because there's no way the average could be here when all the points are lower. Okay. Mean of 3.9, or sorry, still 5.57. Can't be this one for the same reason. So this one's going to have to be point A. And how about 3.91? Okay, it can't be A. No way that can be an average here with all the points up there. So you're down to B or C. Looks like we have a lot of points lower. I think the average is going to be a lot lower than 3.91. That's almost 4. There's only 2 points here at 4. I would say it is C. So that answers A. Calculate the mean for the data set on the other plot. So we haven't done this one yet. So we're going to have to add up those dots. 0.5. And we're going to say 0. I think that's in the middle. We'll go 7.5. 1.5. 1.5. 2. 3.75. 4.25. And 5. And I just wrote down all those numbers right there. So I'm going to add those up. 0.5. 0.75. 1.5. 1.5. 2. 3.75. 4.25, and 5. That is a total of 19.25 divided by how many points we have. 1, 2, 3, 4, 5, 6, 7, 8. So 19.25 divided by 8. I get about 2.4 minutes. Okay, number 2. One of these data sets has a MAD of 0.3 and the other has 0.44. Which dot plot represents that? So the smaller the MAD means the closer the numbers are together. Okay, So which one looks like they are the closest together? I would say C is. And then followed by this one looks the next closest together. MAD of 0.44 is A. So again, we're going to calculate it from B, calculate the MAD. And I'm going to get a bigger number because my numbers are more spread out. So looking at the formula, I already have the average. So I got to figure out how far each one of these is away from the average. Okay, so how far is 2.4 away from 0.5? So 2.4 minus 0.5, I get 1.9. How far is 0.75 away from 2.4? I'm just subtracting, I get 1.65. I got two of them that are 1.5. How far is 1.5 away from 2.4? That's 0.9, again I have two of them. How far is 2 away from 2.4? How far is 3.75 away from 2.4? How far is 4.25 away from 2.4? And how far is 5 away from 2.4? All right. So from your notes on the previous page, this is the distance they are away from the mean. So now I got to add these numbers up. So 1.9, 1.65, 0.9, 0.9, 0.4, 1.35, 1.85, 2.6. I get 11.55 divided by 8. 11.55, and I get 1.44 is my MAD. So again, you'll notice that this MAD is quite a bit bigger than these two. And why is that? Because they are more spread out. Again, smaller the MAD, the closer they are together. Larger the MAD means your numbers are more spread out. Final two questions. Number 3, do you think the three groups are very different or not? Okay, these two are pretty close. You know, the MADs are pretty close. This one is definitely an oddball. Okay, which one is the most accurate? I would say C, followed by A, and then B. And if you were measuring, looks like you're measuring song lengths. I don't know many songs that are half a minute long, so I would say somebody took very poor data here. But I would guess C is the most accurate. Number 4, a fourth album has a mean length of 8 minutes with a mean absolute deviation of 1.2. Is this data very different than the others? Okay, well, if it has an average length of 8 minutes, how do you think that would affect your MADs here? Okay, 8 minutes would be way over here. It would probably really affect this one that was our most accurate. This one here would probably be more accurate because 8 is really pretty close to all these. And this one would get even more spread out. So I would say adding an 8-minute track would make A a lot more accurate. B would make even worse. And C would make worse as well. I would guess that A and C would be a lot closer together with their MAD if you added an 8-minute song to it. All right, again, summary, guys, with some terms there. Median, we didn't really talk about much, but median, remember, is your middle number. And your final homework assignment, guys, 4 questions on page 91 and 92. Talk to you soon, guys. Bye-bye.